Good morning, everyone. Good afternoon. Welcome to yet another informative webinar by Impetus. I'm Lisa Glenn, your host and presenter for today's session on cloud-enabled vis-a-vis on-premise performance testing, a face-off, where we're going to tell you how you can integrate on-premise and cloud-based options to build an effective performance strategy. Today, we welcome back Mustafa Badriwala from the Performance Engineering Group at Impetus Labs as our expert speaker. Now, Mustafa has been involved in the various R&D initiatives and leads the performance engineering engagements for our ISV clients. So let's go ahead and take a look at what today's session has in store for us. Performance engineers worldwide are harnessing that infinite computing power of the cloud to test the performance of their web, mobile, and cloud applications. Now, given this immense popularity of cloud-enabled performance testing, we'll go ahead and discuss how it helps in overcoming the limitations of a test strategy that solely relies on on-premise performance testing. We're also going to discuss the available cloud-based performance testing solutions and whether or not they can effectively fill the gap areas created by the on-premise approach. Later on in the webinar, we'll also share our recommended strategy, which incorporates both on-premise and cloud approach and presents just an effective test strategy for you. But before that, let's go ahead and take a look at the on-premise model. It's aptly named because all of its components, including the tool, recorder, controller, system under test, etc., are deployed within the local environment. Now, the first and the very basic step of on-premise performance testing is to set up a test environment. This would involve putting together a suitable infrastructure, procuring servers, hardware, and software in order to host the load generation hardware and system under test. Now, setting up this kind of an environment would require considerable investment and efforts and has overheads such as license and maintenance costs. Now, you would also need to hire administrators to maintain and support this environment. And since setting up this kind of environment is a costly affair, there is a possibility that you may be requested to share this setup with other teams or for other activities, say for staging environment or for user acceptance testing. Additionally, it's really difficult to scale the test environment to simulate sporadic peak loads because it involves procuring additional servers, licensing, etc., and this, of course, might result in additional expenditure. But this is mostly about the infrastructure considerations. Other significant aspects that we have to consider is how the on-premise model does not measure up to the realistic simulation of the user behavior. Now, of course, your application will get hits from all corners of the world, and therefore the performance of the application should be measured from multiple geographies. Also, while conducting the test from within that local environment, we really ignore aspects such as network latency, firewall behavior, DNS servers, and similar important components in the end-to-end delivery chain. And therefore, we just might not be testing the actual user experience. So basically, these are just some of the limitations of that traditional on-premise approach. And a cloud-enabled performance testing can address these gap areas, and let's go ahead and look at some of those right now. We believe that performance testing with the cloud enables testing teams to take a really big step forward in conducting a more efficient and more realistic large-scale test. Moreover, it enables the organizations to realize significant savings in cost and time, all thanks to that cloud technology. The cloud enables quick and easy setup of the test environment. In fact, it can be up and running in minutes, and we just do not have to worry about the licensing costs of the software, the operating system, tools, and so on, which is a huge advantage. Further, it also eliminates the need of spending a considerable sum to purchase and maintain the hardware and load testing tool that you might otherwise need to buy in an on-premise model. Using the pay-as-you-go model, you can rapidly set up the testing infrastructure that you need, when you need it, and only for as long as you need it. And of course, from a business standpoint, the cloud lowers the total cost of ownership while increasing your flexibility. Now, as you know, many times the web applications experience sporadic surges in traffic. Generating the load for large-scale tests to mimic these unanticipated spikes in the production traffic may require tens or even hundreds of machines. And while purchasing and configuring these systems require a significant investment in time and money, with the cloud, you can just rapidly set up as many load-generating machines as you need on demand using automated provisioning of required hardware. Automated provisioning really ensures that the load generators are consistent and optimized to generate the desired load. Now, another big advantage that the cloud offers is the realistic simulation of test scenarios. With the cloud, you can actually execute load tests that access your web applications as your users will from outside of your firewall, and then can validate all the infrastructure components using the firewall, DNS, network equipment, and ISPs. Now, these tests are significantly accurate and really enable you to evaluate the real-world effects of third-party components, such as content delivery networks, analytics servers, and ad servers. And since your users will not access your application from one particular geographical location, a realistic test load would require simulation from different geographies, and of course, this can be achieved via the cloud. The cloud-based solutions can also be accessed via browsers from multiple devices, such as your PCs, smartphones, tablets, etc. And therefore, you can choose to run and analyze performance tests from really anywhere at any time. So after going through some of the limitations of on-premise approach and discussing how cloud-enabled solutions can address them, do you think that the cloud is the perfect solution for your performance testing needs? Well, the cloud, like every other solution, does have its own set of limitations, and I'd just like to discuss those right now. Let's go ahead and start with data security, which of course is a major concern for any performance testing activity happening via the cloud. This is a critical challenge because the test scripts, test data, and test results are moved to the cloud, and we therefore need to figure out ways through which our sensitive data is not accessed via any unauthorized source. Another problem area that you might encounter is testing intranet applications on the cloud. Here, we actually need to work with the client's IT department in order to receive permission to access the application from the cloud. This now involves exposing the intranet servers to that external world and requires relevant security mechanisms in place to avoid any unauthorized access. And then comes that repeatability and consistency of the test results. So often in performance testing, you need to precisely measure the effect of changes made to the application code or configurations. For example, you may need to determine any improvements that result from resolving a specific defect or maybe evaluate performance for a range of cache sizes and other related settings. With cloud load testing, such precise measurements are really difficult because of the variations in internet traffic and bandwidth availability. So such variations can make it almost impossible to then duplicate uniform test conditions. Now, on the other hand, on-premise testing helps achieve those consistent and repeatable results by being able to isolate effects that are due to our own application or infrastructure. Also, debugging and bottleneck identification also does represent a major challenge while the tests are being conducted from the cloud. When load testing uncovers a problem, the next step is identifying which layer in the application chain is causing the problem. Now, you can use monitors to check the performance metrics such as hits, average response time per request, and average bandwidth for each layer. You can also employ application performance management, or APM, solutions to identify any bottlenecks that you find in the code. These techniques actually work reasonably well when the environment is controlled and free from any external factors. So, moving on to the next problem area, which is test assets management. Since the cloud instances may not be available all the time, it's really important to have a pertinent test data management strategy in place as well. You need to have a proper backup mechanism for test scripts, test data, and test results so that they can be available for reference at a later stage. So, having shared with you all the challenges, we want to know what, in your opinion or experience, is the most critical of them all. So, what, in your opinion or experience, are the most critical challenges in cloud-based performance testing? And you actually have a chance to answer that question on the right of your screen right now. Your options are, first, data security, repeatability of tests, limited control on test environment, test assets management, application monitoring, identifying bottlenecks and debugging capabilities, and finally, testing internet applications. You have a total of 30 seconds to respond right now, and you can actually choose multiple options if you like. Okay, so it actually looks like we have some results, and the top 3 critical areas identified by the audience is data security, testing internet applications, and test repeatability. I'd just like to take a moment and ask Mustafa, who's our expert speaker today, for his take on the poll results. Mustafa?
Thanks, Lisa. A very good morning and good afternoon to all our audience. As expected, data security is a top concern for the enterprises opting for cloud-based solutions like any other testing. And it's true, and I'm sure that in this webinar we would try to address that how we can resolve these concerns and also how we can create a process for testing that ensures repeatability of test results across different solutions.
Okay, great. Thanks, Mustafa. So after going through the benefits and challenges of using cloud for performance testing activities, let's go ahead and take a look at the available solutions in today's world that can help in optimally leveraging the cloud. And we have classified these solutions across 3 major categories. The first and the simplest solution is to move the current on-premise tool to the cloud as it is. A few companies also offer automated cloud provisioning portals for load generations as well as executing and controlling tests. Now, the first 2 categories do have a few limitations, and therefore a third category called the hybrid approach is in place. This category involves using on-premise tools to generate on-demand load using the cloud. Now, it still supports high concurrency testing, while still giving the benefits of controlled environment and security. We're also going to share with you the Impetus recommended two-phase approach, which we believe brings out the best of the on-premise and cloud options and helps one to build a successful performance testing strategy. So let's go over the details of each of these solutions. As we're all aware, there are some standard components of performance testing tools, such as controller, load generator, recorder, and analyzer. The variations in the deployment models depends on where all these components are placed while we conduct the tests. So it's important to choose the appropriate deployment model based on those needs. If you look at the image on your screen right now, you'll notice that in this particular model, all the components of the tool have been moved to the cloud. This, again, is the simplest way to leverage cloud for performance testing and is used by tools like JMeter, Grinder, and LoadRunner. This model is really suitable to test cloud-based applications or internet applications, since these get hits from all parts of the world. The scenarios can be designed in a manner to simulate realistic load across those multiple geographies. This solution helps in generating realistic simulation vis-a-vis an on-premise model, and we also have an option to instantiate as many load generators as we require quickly and on demand. And yes, since there's no hardware procurement involved, there just wouldn't be any massive expenditure on your part on setting up the infrastructure. Another big benefit of this approach is that there's no learning curve involved. The teams are already familiar with the tool and can just start testing quickly. Also, another benefit is that there are no licensing costs involved. So the entire process becomes simplified, and you're only charged for the period you use the cloud infrastructure. Now, on the other hand, unfortunately, there are quite a few limitations of this model. And first, it does require manual configuration of instances and knowledge about the cloud's APIs. Those instances can only be accessed via RDP, PuTTY, or SSH, which involve physical connection to the machines. Also, the test data resides in the cloud, and after the instance termination, it could be lost. So it's really important the user comes up with an appropriate data archival strategy before terminating the instances. Now, let's move on and talk about another popular approach, which is provisioning the tool from the cloud. Now, this involves using the tool provisioned on the cloud for load generation, execution, and test management. All the components of a load testing tool are deployed on the cloud, and the user can then access the solution from the browsers. This really provides an easy interface that can be accessed anywhere at any time. Impetus Sandstorm and some other companies, including SOSA and BrowserMob, provide this solution. One of the major benefits of this approach is on-demand load generation. For example, the user can scale their load tests at any given time. Also, pre-created instances really help in quick scaling of the load tests. This process is best suited for mobile and cloud-based apps that have a large user base and scales quickly. And although this approach is very popular, it also does have a few limitations that you really need to know about. Since the tool is accessed via the internet, data security is again one of the major concerns, because all of the test artifacts and results are stored on the cloud, thereby presenting a real challenge to data confidentiality. Also, since the tests are run over the internet, appropriate firewall access is to be provided for internet applications. Now, due to varying network conditions, the test also might not be repeatable. And it's also really difficult to identify performance bottlenecks in such cases, as the number of variables is relatively high. This approach is well suited for measuring the end user experience and exercising the entire delivery chain, including firewalls, ISP, CDN, routers, etc., in a typical application deployment. Now, let's move on and go ahead and talk about the hybrid approach, which is a great option to try and address the limitations of the earlier two approaches that I just talked about.